Here we're going to try and find the derivative of the function f of x equals x cubed using the definition of the derivative. Of course, and don't lose sight of this, we know from our shortcuts that if f of x is equal to x cubed, then it's a polynomial, so multiply down by the power, reduce the power by 1, the derivative should be 3x squared. So that's a shortcut, but that's sort of an artificial way of doing this. And if we want to use the logic, the traditional way of doing it, and in other words, use the derivative, or use the definition of the derivative, this is how we'll do it. So that's f of x. So f of x plus h, we're going to need that as well, because that's part of the derivative. That would be x plus h cubed. And if you remember your Pascal's triangle for binomial expansion, if you don't remember it, look it up. But if you do remember it, that would be x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay. Now, the definition of the derivative says that f prime of x, the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's start to fill the top line of that in. That's going to give you the limit as h approaches 0. f of x plus h is x cubed plus 3x squared h plus 3xh squared plus h cubed minus f of x. So minus f of x is x cubed all over h. Well, you have x cubed minus x cubed in there, so you can remove those. Okay, because take one away from the other. And on the top line, we have a h in every term that's left. So let's factor h out of the top line. And that gives you the limit as h approaches 0. Okay, let's factor h out. That'll give you 3x squared h plus 3xh squared. Oh, sorry, 3xh plus h squared. What we've done here, we've factored the h out of each term on the top. On the bottom, we still have a h. Now, the h on top is outside parentheses, which means it's available for cancelling. So we can reduce this fraction by cancelling that h with that one. And now, what we've got, if we look at this, is we've got the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And if we substitute now, that's going to be 3x squared plus 3x times 0 plus 0 squared, which is going to be 3x squared. Okay. Now, that's exactly the same as what we had way up here. A much longer way of getting to it, and that's why the shortcuts were developed, because using the definition of the derivative is a little bit inelegant and takes a lot of time. So having the shortcut makes your life an awful lot easier. But this is how the derivatives were originally calculated. Okay, you won't have to do much of this. In fact, you probably won't have to do any of it this year, but it's important that you see how it works.